Hello, today I am going to introduce the economic growth. In simple macroeconomic models, we do not consider the time. The time is considered for the short period. There is no technological change and population growth of population is constant. This type of assumptions are there in the simple macroeconomic model. Another way we can say that in the simple macroeconomic model, net investment only affects the aggregate demand, but net investment has an effect on the productive capacity of the economy. This type of understanding is not considered in the simple macroeconomic model. When the net investment affects the productive capacity, we consider the economic growth model. And if you here there are some assumptions in the simple macroeconomic model I have said. First is the time period is short. And second is an unchanging level of technical knowledge. The technical knowledge is constant and also the constant population. So if you have the time period is constant, the investment only has the effect on the aggregate demand. It does not find time to affect the productive capacity. And unchanging level of technical knowledge. Technical knowledge or technological knowledge has an important effect on the economic growth, and it is proved. So technological change should be considered. A constant population, a constant population, actually in simple macroeconomic model, the population is constant, but in real situation, the population is increasing or population increases at a at a geometric progression. At a geometric progression, population increases. So these type of factors do have effect on the economic growth, and the effect of these factors has some impact on the economic growth, and this is considered in an equilibrium situation. The reason for concentrating on equilibrium solution, why we are considering the equilibrium solution, there are 2 points. First, the equilibrium dynamics solution is easy to set up and it is easy to solve compared to the disequilibrium dynamic system. Because in the disequilibrium dynamic system, there is a lack structure, and there is error, and the analysis is complex. And the second point where I have mentioned that the neoclassical economists believe that the economy is inherently stable, but Keynesians and neo-Keynesians believe that a capitalist economy is inherently unstable. Now, in order to throw some light on these difference of opinion, it is necessary to examine the conditions necessary for the existence of full employment equilibrium growth and the stability of the equilibrium growth path. Okay, now I am erasing all this point. Now, the here look the impact of capital accumulation and population growth. Now we consider the impact of capital accumulation and population growth on economic. Here is a aggregate production function. Look at this, the production function. And this production function, Y is the real output. And L is the labor, amount of labor, K is the capital stock, and T is the technological change. The law of variable proportions is applied here. And not only the law of variable proportions is applied here, and as a result of this, in the absence of technical change, an increase only one type of factor keeping other factor constants decreases the output. The rate of increase of real output is, is declining. So this is the law of variable proportion. What is the law of variable proportion? Keeping the other factors constants, if one variable is increased, then the dependent variable here is the real output is increasing but at a declining rate. So this is the aggregate production function, and the law of variable proportion is applied. Now, for simplicity, for understanding the whole situation, we consider there is a constant returns to scale, and the whole experiences is that a given proportionate increase in both capital and labor inputs per period of time will lead to the same proportionate increase in output per period. That is, if we increase labor constant term, then output will also increases by that amount. And this constant returns to scale shows us that this aggregate production function is linearly homogeneous function in K and L. So this situation implies that if we multiply y by a theta constant, L should be multiplied by a theta, K should be multiplied by a theta, and T should be multiplied by theta. And T is constant here. We have taken it as a constant. Now, if we substitute the theta equal to 1 by L, then we get this situation. Then you get this situation, that is y by L equal to function of 1 by k. 1 and k by L by t bar. So this can be written as y by L f k by L. Now, after rearranging, we find this. Y equal to L and the capital labor ratio. So real output, so the real output is a function of labor and capital output ratio. Now, here is the law of variable proportion is applied. So if the capital increases more than the labor, then capital output ratio will increase, and as a result of this, output output will increase but at a declining rate. Conversely, if labor increases more than the capital stock, then also output increases but at a declining rate. If capital and labor increases at a constant rate, then real output will increases will increase at a constant rate. It is known to us that the marginal product of a factor is used to pay the labor. So real wage rate or real interest rate is determined by the marginal product of labor and capital respectively. So if the capital labor ratio increases, if the capital and labor ratio increases, it means that the marginal product MP of K, marginal product of capital will decline. Marginal product of capital will decline. And as it declines to real wage rate, then real wage rate, so real capital, real interest rate will fall. And if capital labor ratio falls, that's when labor increases more than the increase in capital, then also marginal productivity of labor falls, and as a result of that, the real wage rate will fall. And this is required, that means the fall in real wage rate or fall in real interest is required to maintain the equilibrium. Now, suppose that labor is constant. Now, suppose labor is constant and capital is increasing. So, on the basis of the law of variable proportions, and it is clear that real output will increase but at a declining rate. That's when capital increases, the rate of increase in capital and rate of increase in output is not the same. The rate of increase in output is lower than the rate of increase in capital. Okay? And here is a gap. And in our next figure, now I am erasing all this, okay? I am erasing all this point, all this marking. Now, if you, in my next slide, here along the Here, along the vertical axis, we measure the per capita real output, that is Y by L, and along the horizontal axis, we measure the capital labor ratio, that is small k or K by L. If K by L increases, if K by L increases, then Y by L or real output will increase but at a declining rate. So here is the growth path. Here is the growth path. That is, if net investment has an effect on the productive capacity, then, then there is a growth path. Then there is a growth path. So, and if now, now in my in my now I am deleting all this marking, and I am and now I in my next the previous slide, that if labor is constant and capital is increasing, and real output will increase but at a declining rate, and and if incentives for entrepreneurs to invest are to be maintained, the growth in the capacity to produce output must be matched by an increase in aggregate demand. Otherwise, the growth of excess capacity will choke off any desire to invest. Therefore, as long as net investment is positive, therefore, as long as there is net investment is positive, any solution for income over time in a macro model must involve some growth, path for income rather than a stationary long run equilibrium, value. So now there is a question: what is the stationary equilibrium? Look, a stationary equilibrium A stationary long-run solution for income can only occur when there is no technological change or technical change, and when there is a labor is constant, there is no net investment, and zero savings. If these factors are there, then the stationary long-run solution is there. But if there is a positive net investment, then it has the effect on productive capacity, and we have a growth path. Now I'm also erasing all this. Now we introduce the labor force in our model. If we introduce the growth in labor force so that the long run supply of labor grows at a steady exponential rate, here the steady exponential rate is mu, then we have a equation. Look at this equation very carefully. This is labor, and this is the autonomous part, and this is another part, that is the labor is increasing at the exponential rate mu. Now, there is a non-linear relationship because the labor force is increasing at a geometric rate. So now, if we take the natural log of this equation, then we get, on the basis of the log formula, we get this. That is log L is equal to log L0 plus mu t. And this is the non-linear relationship, and this is the linear relationship. Okay. Now, this linear relationship, if we take the it in our pictorial presentation in our graph, then we find, now I am erasing all this marking. Okay. And now this slide, in this slide, along the along the vertical axis, we measure the labor, and along the horizontal axis, we measure the time. And in the second part, we measure the log L along the vertical axis and measure the time along the horizontal axis. And this is the non-linear curve, and this is the linear curve. Okay. Now, now, if the labor force is increasing at a rate, then the capital stock, and it can be found in our previous slide. I am going to this. Okay, the basis of that video here. Look, at this. Here, labor is increasing. Suppose L, this L, this labor is increasing, and it increases more than the rate of capital stock. Then capital output ratio falls, and real output and real output and real output and real output will increase, but at a declining rate. But if labor capital is constant, and labor is increases, then capital labor ratio will fall, and real output also increases, but at a declining rate. Again, if we have a constant increase in the real output, then labor should be increased at a constant exponential rate such as mu, and capital should be increased at a constant exponential rate such as mu, and price should be increases at a and money supply should be increases at a, and the stock of money must also grow at a constant rate mu. Only that in that situation, the real output will increase at a constant rate. Okay, this is the impact of labor force, growth of labor on the economic growth. Now I am deleting all of my marking, and now I am going to my next slide. Okay, look at, so when the labor force, what I have said, that when the labor force is growing at some exponential rate mu, income per head, that is y by L, can only stay constant if the capital stock is also growing at will. Okay, and so is aggregate demand. In this situation, all the flow variables must also grow with time at an exponential rate. The stock of money must also grow at this rate in order to keep the price level constant. Such a rate of growth in all the stock and flow variables would keep the real rate of interest and real wage rate are constant. So, what is the crucial point here? The crucial point here is that the real rate of interest and the real wage rate are constant. Why it is constant? Why and is a constant? Because to make it constant, we increase the labor at exponential rate mu and money stock at an exponential rate mu and 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 so and as a result of this we get the real rate of interest and real wage rate constant real rate of interest and constant real rate and real wage rate. So the above discussion, what I have discussed, it is proved that, and it is shown that any equilibrium solution in a macro model that includes capital accumulation and population growth must necessarily involve finding some growth path for the level of income. That means if the capital population, so capital accumulation and population growth are to be considered, then there is a growth path for the level of income. Okay, I am now erasing all my markings. Okay, now in this slide, look, an equilibrium solution in a growth context of a closed macro model with goods market, and there is a money market, and also there is a production sector. That means in a growth context, in equilibrium solution in a growth context, and the economy is a closed economy, and there are three markets. One is goods market, another is money market, and the production sector. So the production sector, these three things are there. Then there is a growth path, and in that growth path we have the 4 points. And in that growth path we have 4 points. One, the first point. What is the first point? The first point is the desired investment and government spending should be equal with the desired saving plus taxes. That is, are equal to desired savings and plus taxes. That is, at every moment in time, desired investment and government spending are equal to desired saving plus taxes. Okay, and there is another condition. What is the condition? The condition is that the money market, the money market, the money market is in equilibrium. That is, the demand for money should be equal to the supply of money. And the third condition is that full employment is there, and there is equality between desired and actual capital stock. Is the fourth condition. Now, the growth models without a money market, suppose there is no money market, will have an equilibrium growth solution, and there should be three conditions, and these three conditions should be fulfilled. What are those three conditions? Condition A, condition C, and condition D. That is, at every moment in time, desired investment and government spending are to equal to desired saving plus taxes, and there is full employment, and there is a equality between desired natural capital stock. Okay. Now, while the simplest growth model, which considers only the goods market, now if we consider only the goods market, then only two conditions, condition A and condition D. Condition A, that is the desired investment and government spending, are equal to desired saving plus taxes, and there is equality between desired and actual capital stock. Okay. Now, it is easier to develop the condition. So, if we, in case of policy implication, the money market should be included, and it will create a complex model, and it is and it calculation is very difficult, and so so such type of models are considered where there is no money market, and that type of simple model, there is Harrod model, John Robinson model, Solo model, Swan model. And Harrod, John Robinson, Solo, and Swan are the pioneers of such code model. So we can say that it is easier to develop the conditions necessary for the existence of an equilibrium growth path and examine the stability properties of such a path in a simpler models which exclude the monetary sector. And such type models are Harrod, John Robinson's model, Solo's model, and Swan model. So in our today's lecture, I have I have introduced the economic growth. Why there is a economic growth, and what is the place in macroeconomics, and how it takes place in a macroeconomics. In simple macroeconomics, there is no growth concept, because only the aggregate demand it is considered in the simple macroeconomic model, where, for example, the net investment effect on the only has the effect on the aggregate demand. But in the growth model, this the net investment has an effect on the on the productive capacity, and that gives us a growth path. So hope you have a clear idea over the economic growth, and thank you all of you. Thanks.